Hey guys, how are you? I hope all you doing well. Okay. So today we are going to discuss about the electrophilic substitution reaction in your haloarenes. Okay. So first of all, what is electrophile? What is electrophile? The species either positively charged, or electron deficient, either positively charged or electron deficient, okay. So I will give the example. Look here, whatever the electrophile which we are going to discuss it now, okay, we are going to discuss those electrophile. Okay, look here, if I am taking the FeCl3 and Cl2, then HNO3 and H2SO4, sulfuric acid and nitric acid. Then third one, we are taking the H2SO4, just eating. Then there is a fourth one, your AlCl3 react with your CH3Cl. Okay. Then fifth one, AlCl3 react with CH3 C double bond O Cl. Okay. So I will give the electrophile which is generated in the all 5 changes. Okay. So first one, there is a formation of FeCl4 minus and Cl plus. In the second one, there is a formation of NO2 plus. In third one, there is a formation of SO3. Then fourth one, CH3 plus. Then fifth one, CH3 C double bond O plus. Right? So this is positively charged. So this considered as electrophile. This is also positive charge. This is considered as electrophile. In case of this one, this is neutral, right? But still, the oxygen is more electronegative. The electron will move towards the oxygen. So here there is a electron deficient. So we need to write the sulfur is less electronegative compared to the oxygen. That is the reason why the sulfur electron deficient one here in case of SO3. Okay, so CH3 plus is positively charged, CH3 C double bond is positively charged. These are all electrophile going to react with your haloarenes. Okay, there is a formation of ortho and para product. Why it is formed the ortho and para product? Look here. Although the benzene is bonded with halogen which is deactivating and electron withdrawing. Okay, so due to this, the electron density on ortho and para position slightly get decreased, right? But here there is one more effect it is there, that is resonance effect. Okay, the lone pair of electron over the halogen. Okay, so coming to benzene ring at the time, it restricts the electron density decrease over the ortho and para position. Okay, so the reactivity is controlled by your minus A effect. Okay, but orientation of incoming group, okay, the incoming electrophile, which position it has to bond, okay, that going to be controlled by your resonance effect. Clear? One more thing I want to explain. Your benzene is more reactive towards your electrophilic substitution reaction. Benzene is more reactive compared to your halobenzene. This is because here there is a presence of deactivating group or electron withdrawing group. So due to this, it need the vigorous condition to conduct the electrophilic substitution reaction. But in case of this, the speed of the electrophilic reaction is more on benzene compared to your halobenzene. Clear? Right. Then next we go for there is a 3 types of reaction we have discussed already. If a 2 alkyl group react in presence of sodium and dry ether, then we call it as a Woods reaction. Okay, this two alkyl group bind. So whatever the number of carbon is there, double number of the carbon in the product. Okay, this is Wood's reaction. If I take the two haloarenes, the same condition, the sodium and triether, if I use, then this is Wittig reaction. Then this is Wittig reaction. So in the Wittig reaction, we are going to get the biphenyl. In the Wittig reaction, we are going to get the biphenyl as a product. In case of one aryl halide, one alkyl halide, it react to get alkyl arene as a product. Alkyl arene is the product. Then this reaction is Woods-Wittig reaction. Woods-Wittig reaction. Right? Shall we solve? Shall we solve the question 6.7, 6.8 and 6.9? Okay. So first of all, which of the alkyl halide from the following pair would you expect react more rapidly in SN1 mechanism? Okay. So we know that, right? If it is SN1, your tertiary is more reactive than secondary, then primary. In case of SN2, your primary is more reactive than secondary, then tertiary. Right? Okay. Look here. This is primary alkyl halide. This is secondary alkyl halide. Obviously, your primary alkyl halide is more reactive towards the SN2. Clear? So this is secondary. This is tertiary. Then your secondary is more reactive towards the SN2. Then when it comes to this is also primary. This is also primary. In this case, your alkyl, okay, your alkyl, the bromine bonded carbon in a alkyl halide, your bromine bonded carbon connected with bulky group, right? But in case of here, the bulky group somewhat far from your halide bonded carbon. Okay, so if it bulky group present, okay, on or near to that carbon, okay, your SN1 it's more reactive, okay, compared to your SN2. So this is your bulky group away from your halogen bonded carbon. So this only more reactive towards the your SN2. Clear? But in case of 6.8, they are asking which one is more reactive, which one is more faster in case of SN1. Okay, we know that, right? This is tertiary, this is secondary, this one is more reactive. This is secondary, this is primary, this is only more reactive towards the SN1 reaction. Okay, when it comes to this one, what is the product of A? The A is your cyclohexyl magnesium bromide. Cyclohexyl magnesium bromide. This is cyclohexyl magnesium bromide is a A. Okay, what is B? So we know that, right? This is more electronegative. The carbon is more electronegative compared to magnesium. This is delta minus, this is delta plus. If it in case of H plus OH minus is there, this minus abstract the proton. Okay, at the time your B is cyclohexane is the product. Clear? So we go for next question. Look here. Your R and Br, it going to give rise to RMGBr. So in DTO we know that, right, D plus OD minus. Okay, the D plus get abstracted by the alkyl group. Okay, so then your R going to be CH3 CH CH3 Br. Okay, so when it react with magnesium, what it going to form? Shall I do it in bond line formula? This is MgBr. So this is negative, this is positive. If it abstract the proton, D plus OD minus. If it abstract the T plus, your product going to be formed. Clear? Next, when it comes to this one, what is the name of this one? 1, 2, 3, 4. So 2, 2 dimethyl, 2, then 3, 3, 2, 2, 3, 3. Tetramethyl butane. Okay, so your reactant going to be your CH3 C CH3 CH3 your X. Okay, so 2 times of it. Here there is a number of carbon is 4, so double number of the carbon, so 8 carbon. Okay, so when it react with the magnesium, what it going to form? Shall I do it in bond line formula? MgX. When it react with H2O, So this is delta minus, this is delta plus, this is going to abstract the proton. There is a formation of this one. Okay, so this is 1 2 3, so 2 methyl propane is your product. Clear? So we go for next. So we are going to discuss the uses and what are the demerits of your polyhalogen compounds. So first thing first, what is polyhalogen compounds? What is polyhalogen compound? The carbon compound contain more than one halogen atom are usually referred as polyhalogen compound. Okay, so the first one is dichloromethane. When it comes to dichloromethane, what you just remember the two uses and what are the demerits. Okay, two demerits, that is more than enough in the case of your polyhalogen compounds. Okay, so it is used as a paint remover, it is used as a propellant in the aerosol, then metal cleaning and finishing solvent. Okay, then it lead to slightly impaired hearing, okay, and vision. Eye level causes dizziness, nausea and tingling numbness. Okay, this is more than enough. Okay, in case of chloroform, the chloroform nothing but trichloromethane. Okay, so trichloromethane, so we know that, right, chemically the chloroform is employed as a solvent for the fat and alkalides and iodine. Then it is used, okay, uses of chloroform today, the production of refrigerant R22. Then it is act as anesthetic. Okay, due to this toxicity, now we are using ether as a anesthetic. Why we are not using chloroform as anesthetic? Because this is little bit toxic. Okay, that is the reason. Okay, then this demerits, the 900 parts per million causes dizziness, fatigue and headache. Okay, then it is also form the potent poisonous gas, that is phosgene. Okay, so the CHCl3 exposed to light in presence of O2, it is going to form the phosgene. Okay, that is more poisonous. Okay, that is the reason why stored in closed dark colored bottle and completely filled so that air is kept out. Clear? Then we go for the iodoform. In case of iodoform, it is act as an antiseptic. Why it is act as an antiseptic? Okay, it is act as a antiseptic. When we apply on the wound, at the time there is a liberation of I2 take place. That is the reason why it act as a antiseptic. Okay, so the property of antiseptic due to liberation of free iodine, not due to iodoform itself. This thing very important. Okay, then there is a tetrachloromethane, right? This tetrachloromethane, it is used for the manufacturing of refrigerant and propellant in aerosol. Okay, then used as a feedstock, synthesis of chlorofluorocarbon. Okay, then this demerits, we can say the carbon tetrachloride causes liver cancer in the human, and most common effect are dizziness, headache, nausea and vomiting. Okay, so then also this effect can lead rapidly stupor and coma. What is stupor? You tell me in the comment section. Okay, then unconscious and death. Then it is also deplete the ozone layer. This lead to more harmful ultraviolet comes to your earth. Okay, at the time it affect the human. Okay, in case of freon, the chlorofluorocarbon of methane and ethane collectively known as freon. This is important. Okay, the chlorofluorocarbon of methane and ethane collectively known as freon. Okay, so this is extremely stable, unreactive and non-toxic and non-corrosive and easily liquidable gases. Okay, so it is manufactured from the tetrachloromethane. Okay, when it react in the Schwarz reaction, when it undergo the Schwarz reaction, at the time there is a formation of chlorofluorocarbon. Okay, so Then its demerits, okay, its demerits, we know that, right? It depletes the ozone layer, okay. That is the main demerits of this chlorofluorocarbon. When it comes to DDT, I will tell you the first of how to name the DDT. So this is para position. If this is para, this is considered as a para dash. So para dash dichloro, okay. Then how many phenyl group is there? Diphenyl, okay. Dichloro, diphenyl. Then trichloroethane. So para dash dichloro, diphenyl, trichloroethane. This is the name of the DDT, okay. So this is, okay, very effective against the mosquito that spread the malaria and the lice which is carry the typhus, okay. Then this, when we use the predominantly at the time high toxicity towards the fish and the chemical stability of DDT, which is stored in the your fat, okay, stored in the fat. So that is the reason why it is banned in USA, okay. This causes biomagnification. This will causes the biomagnification. This biomagnification you will study in the last unit of 12th biology, okay. Thank you all. Thank you so much watching my video, okay. Do perform well in the exam. All the best.